Hello students, in this lecture we are going to start with motion that is mainly in one dimension. So this motion basically if you see that comes under your mainly mechanics, where we are just going to study the position of an object. It might be at rest or it might be, you can say that it is a moving. Then again you will say that mechanics we will classify into that is nothing but your mainly kinematics. So in kinematics, we will see that the object, which is again, we have to study the position of the rest. Again, it might be in the motion. So now in motion, we are going to study the motion in the one dimension. So that's why we are just calling it as a one dimension. So what do you mean by that one dimension? Then what is that motion? So let's say, for example, so these are the topics which we are going to cover. So what do you mean by frame of reference, rest and motion? What are the different types of motion? Some important terms, graphs, kinematics equations, motion under gravity. Then what do you mean by relative motion? So all that we are going to just cover over here. So let's start with this. First, a frame of reference. Now, what do you mean by that frame of reference? So basically, frame of reference means from which frame you're observing the things or you're observing the experiment. So let's say, for example, you are just on that your ground frame. So let's say you're just standing on that ground and the train is passing nearby you. So you can just say that. So you just measure the speed of that train. So let's say that x is the speed of train. So the speed of that train, let's say it is 100 km per hour. So that is with respect to you, and you are on the ground. Again, you are just standing on the ground, so you're not moving at all. So basically, frame of reference means from where you're calculating the things, from where you're going to measure the various physical quantities. So that basically we will call it as a frame of reference. So the same thing we defined over here. The frame of reference or a reference frame is a perspective that one uses to determine if an object is moving or not. If the train is stationary and you are also stationary on the ground, then simply I will say that the train is not moving. With respect to you, the train is at also rest. So that is what we can say that your frame of reference. Again, we will say that. So sometimes we will say that now you are standing on the ground surface and you are saying that definitely you're standing on the earth or the ground, and that earth itself is also revolving at a certain very slow speed, but certainly it is revolving. And with respect to that, you are calculating the speed of any object. So that means you can say that. So this is again not, you can say that it is an absolute your velocity that you can say. So it is a relative velocity with respect to you, because you are yourself also revolving, but you can't just notice that. So as the earth revolves, the various things on the earth surface, they are also revolve, and the train is also moving. So that is, we can say that it is nothing but again a relative velocity or the relative measurement that we are doing over here. But generally, just for that physics point of view, just for the moment, we say that all the things are at rest. So that means we are observing the things from the ground frame, which is moving at some constant velocity. So let's say that is nothing but the frame of reference which we are considering, or most of the time we are just considering that your XYZ axis, that is nothing but your frame of reference. So this is what we can say for this frame of reference. Then the next thing, a very important thing. So let's define that. What do you mean by that rest and the motion? Both the words are very important. So let's say I'm just giving you the lecture to all of you and you're listening. So that means I'm at rest position. So I'm not going to change my position for the, let's say, next half an hour. So I'm at rest. And again, motion. So definitely the motion means the object is going to change its position. So again, a very important term, that is nothing but we will say that. So what do you mean by position? What do you mean by position? And we just discussed that the position is nothing but with respect to some fixed coordinate system. So if I'm saying that, so let's say this is x, y, z, this is your coordinate system, and this is, let's say, 0, 0, 0. So with respect to this coordinate system, what is your current position? What is your current position? And we can say that, so that position we have to define with respect to some fixed coordinate system. So that is nothing but your position. So if again I will say that rest means definitely the position of the body is not going to change. Right now at 1 o'clock I'm just over here, and 2 o'clock also I will be over here itself. So my position is not going to change at all. So that is nothing but your rest. So that is nothing but your rest condition. Now the second term which I'm just saying over here is nothing but the motion. So let's, once my lecture gets over, definitely I just went out and definitely my position is going to change. My position is going to change. So I'm just moving from one point to the another point. So where I will say that the position is continuously changing, then I will say that I am in the motion, or the object is in the motion, where I'm just going from one point to the another point. So that is what we will call it as nothing but the motion. So both the things are very important. One is nothing but your rest, where its position is not going to change with respect to time, or with respect to that coordinate system. This is what we can say about that, your rest and motion. So when the position is not going to change, then I will say that the object is at rest. And when the position is going to change, let's say with respect to time, so then it is nothing but in the motion. So the same thing we had just seen over here. The object is going to move from A to B. So obviously its position is going to change. So that is what we can say for this here. The object is in the motion. Now coming to the next point. So there are different types of motion. Mainly that we will say that the 1D, that we have to do the detail analysis for that. Then the 2D, and again then what do you mean by 3D? So if I just consider that one-dimensional motion, so initially we have just defined that your coordinate axis. So we know that, let's say it is a XY. So we can say that, let's say for example, the object is going to move along the x-axis. So if initially it is at 0, 0, now let's say after a certain time it comes to 2, 0. So you will say that only the x coordinate is getting changed. So initially it was 0, 0, and now it becomes 2, 0. So that means the x coordinate is getting changed. So we will say that this is a one-dimensional motion. Why? Because only the x coordinate is getting changed. So that's why we will say that this is a one-dimensional motion. Now it might be along y-axis, or it might be along the z-axis also. So it might be, in case of y-axis, it will move something like this along the y-axis, or in case of z-axis, so it will move along that only z-axis. Now one important thing over here that we will consider. So this reference system or that coordinate system, it depends on you which coordinates or which point you have to choose as a origin. It's up to you. You can just choose according to your convenience. So based on that, so this is what we can say for this one dimension. Then if we talk about the two-dimensional motion, now in case of two-dimensional motion, both the coordinates means definitely the x as well as the y coordinate is going to change. So let's say for example, if I consider this is the projectile motion, where I'm just throwing the object with certain velocity. Let the velocity is u. This is again x coordinate. This is y coordinate. So initially the coordinates were 0, 0. Then after each interval of time, or you can say that with respect to time, you can say the x as well as the y coordinate is also getting changed. The x as well as the y coordinate is also getting changed. Then definitely there is a variation in the x and y when the object is performing this motion. So this is a two-dimensional motion where x as well as y coordinate, it is getting changed. So this is what we can say for this two-dimensional motion. Now again, this is a two-dimensional motion. So let's have one interesting question. For example, if I say that, so this is your x coordinate and this is nothing but your y coordinate, and let's say this is the line which I have drawn. So this is the motion of the object. So what do you think that whether it is a 1D motion or whether it is a 2D motion? So if we consider that, if you remember, I told you that this coordinate system, it's up to you. You can select according to your convenience. So which one you want to select as nothing but your x-axis as your y-axis. So I will just, according to looking this diagram, I will say that it is a 2D motion, but definitely it's not. You can make it as a 1D motion. So now how you will just make it as a 1D motion? Then definitely I will just consider over here. So I will consider this as a x-axis and this was a y-axis. So I will consider this is the motion which is along the x-axis. So that is nothing but your one-dimensional motion or 1D motion. So this is nothing but your 1D motion, that is a motion along this line or which is nothing but along x-axis. So that is your 1D motion and not 2D motion. Again, if you consider that the motion along the circumference of circle or the circular motion, that is also the best example for your 2-dimensional motion, where you know that the coordinates, or you can say the equation for circle, x square plus y square is equals to r square. So you can say that x as well as y is getting changed. So this is nothing but your 2-dimensional motion. So this is one example. Again, 3-dimensional, where all the 3 coordinates x, y as well as z, the motion of various particle in the space, the aeroplane, you can say that. So there might be possibility that it is moving in that your 3-dimensional motion. Yeah, fine. So this is how we can say that about your 3-dimensional motion.